Okay, here we have an inequality on the number line. We can see that we've got a closed circle here at 4 and an open circle here at -1. Now that tells me that -1, so we're looking at the inequality that's represented by all of the numbers between -1 and 4. 4 is included, -1 isn't included. Now it doesn't really matter what letter we use. I'm going to use X for all of the numbers that I have. And we can see that X is going to be less than or equal to 4 because the 4 is included there, and at the same time X is going to be larger than -1 because the -1 is not included. So notice I've got an equals here but not for the -1, and that's the answer to A. Okay, for B, solving an inequality is just like solving an equation, except you turn the inequality sign round when you multiply or divide by a negative number. So let's see what I can do here. Well, first of all, I'm going to remove the brackets. So 2 times y is 2y. 2 times -3 is -6. And that is greater than or equal to 1. So don't have to do anything with that. I've now got, in the same way as an equation, I'm going to try to get y on its own. So I'm going to add 6 to both sides first of all. So the left-hand side now, all I've got is actually 2y because I've added the 6 back on. I'm adding 6, inequality sign, there's no need to change it. 1 plus 6 is just 7. And now to get y on its own, I'm going to divide both sides by 2. If I divide by 2, the left-hand side becomes y. I'm dividing by a positive number, so no need to turn the sign around. On the right-hand side, I've got 7 divided by 2, which is 3.5. So the answer there, y is greater than or equal to 3.5. Now, part 2 is relating to part 1 here. Y is greater than or equal to 3.5. Now, an integer is a positive or negative whole number. So if I just do a few numbers on a number line, 3, 4, and then 5, this inequality is saying y is greater than or equal to 3.5. So we are looking for a number which is an integer, and it is greater than or equal to 3.5. So the first integer that we get to, which is greater than 3.5, is this one, which is 4. So the smallest integer which satisfies this inequality is going to be 4.